Hello and welcome to this short tutorial on one of the Explore apps, G-TOMO. In this video we will highlight how to use this application and the scientific data that can be produced with it. G-TOMO is one of 6 scientific data applications that can be found on the Explore platform. For more detailed information on its features, you can always consult the corresponding user manual. G-TOMO provides access to a variety of datasets that contain information on interstellar extinction and dip carrier density distributions. Extinction has a substantial effect on data obtained from stellar observations. Therefore, gaining a comprehensive understanding into its exact impact is critical to ensure accurate conclusions are drawn from the data. With G-TOMO, the user can enter any interstellar target or list of targets and view the corresponding extinction profiles in either one-dimensional, two-dimensional or three-dimensional representations. The user can navigate between the different types of profiling tools using the tabs at the top of the page. A different dataset can be selected in the drop-down menu on top. The different datasets provide extinction insights based on the user's specific accuracy needs. The Extinction Profiles page helps to construct one-dimensional extinction profiles. You can choose to enter either a single target or upload a list of targets. The selected targets can be inputted both by the coordinates or the name of the object as resolved by Simbad. Be sure to check the correct box based on your chosen input type. Additionally, a distance point can be added to the profile at the bottom. If you choose to upload multiple targets, be sure to check the Information tab to find the correct format for your input file. After pressing Submit, you can now load your profiles using the drop-down menu above the Access Systems. Use the Download CSV button to store your data. The next step in the header brings you to the Integrated Extinction tool. This tool provides integrated extinction values for a list of sky positions. For this you will need to specify both input coordinates and distances in your input file. The tool is well suited to extract extinction values for a bulk of targets. Again, results can be stored using the Download CSV button or exported to your Explore user space using the Export option. The third tab allows you to create 2D extinction maps. The 2D contoured map is constructed by making a slice in a 3-dimensional dataset. The sliced section is defined with 2 inputs from the user. Namely 1, the coordinates of the desired map's origin, and 2, by defining the orientation of the map's plane in 3-dimensional space. The orientation can be specified by defining the normal to the plane of the sliced image. After specifying your inputs, click Submit to create your map. Within the tool you can interact with the map by zooming in to specific areas or by hovering your mouse over a certain data point to discover additional information. Once again, the map can be saved by clicking the Download CSV button. A 3-dimensional representation of the extinction can be created in the tab 3D Extinction Viz. In the panel you can find a volumetric rendering of the dust cloud structure. It is possible to extract a subset of volume from the dataset using the Select Subcube option on the left-hand side. Furthermore, you can use the Slice tool to create a 2D representation of a desired area. The slice tool can be activated by pressing Z and double-clicking on a point in the plot. The orientation of the slice can be changed using the sliders below the plot. After confirming the desired slice, results are found in the plot on the right. The final tool present in G-TOMO can be found under the header Extinction Sky Map. It displays the integrated dust extinction in a sky map. It is composed by combining multiple datasets. It is possible to create different views using the slider at the top or by changing the scale settings at the bottom.